Hi, I am Bero. I am one of the principal open source architects working on the Eclipse Foundation's Oniro project, an IoT operating system that can support multiple different kernels, such as Zephyr for Cortex-M microcontrollers and Linux for higher-end devices. In this talk, we are going to take a look at the GPIO APIs provided by these two kernels, and trying to find a way to make something work on both, with as much code reuse as possible. First, for the sake of context, let's take a quick look at what Oniro and the Doorlock blueprint are. Oniro is an Eclipse Foundation project focused on the development of a distributed operating system for consumer devices. It's completely open source and intended to run on all the devices you get in contact with. There's a big need to finally unify all the hundreds of thousands of different IoT device code bases out there. And as an important part of this project, we develop what we call blueprints. That is fully open source software and as open as possible hardware that can be used as a base solution for your own IoT projects. One of those blueprints is the Doorlock blueprint. Let's see what it does by taking a look at it in action. When we first power it up, the LED on the Arduino board starts flashing, which means it's ready to learn the pin that will be used in the future to undock. Obviously that pin is stored in non-volatile memory, so even if a burglar manages to reboot the system, that doesn't help him. Let's pick a pin that is really secure that nobody could possibly guess, like 1, 2, 3, 4. Since the system doesn't limit us in the length of the pin, we have to tell it we are done by pressing those two keys at the same time. Now the LED has stopped flashing. That means it's now operating in normal mode, waiting for someone to enter the correct pin. So if we enter something that's not the correct pin, nothing will happen. And if we enter the correct pin, 1, 2, 3, 4, our lock opens, we can open the door, and then it is automatically relocked. Of course, we can also change the pin. To do that, we enter the right pin to make sure it knows where we are allowed to do it, and we press our two special keys again. Now the LED starts blinking again, and we are ready to enter the new pin. One special feature is that the pin can include multiple digits pressed at the same time. So let's still use 1, 2, 3, 4, but 2 and 3 pressed at the same time. 1, 2, 3, 4, and we are done. The LED stops flashing, and our old code of 1, 2, 3, 4 just won't work anymore. But 1, 2 and 3, 4 opens our lock. So, as you have seen, we have a nice